Hi everyone, I'm Hyung-Tang Lee from Korea University. Today I will talk about decoding the performance of the memory task using single trial intracranial EEG. In previous study, it is well known that distinct brain activity patterns are shown when successfully remembering and forgetting a specific item in a memory task. The memory task is divided into an encoding session to memorize presented items and retrieval session to retrieve memorized items. Most of previous studies attempt to decode the performance of the memory task using brain activity measured in retrieval session, but which cannot predict whether the memory task will be succeed or fail in advance. Therefore, decoding the performance of a memory task using before or during the encoding session cannot only predict whether the memory task will succeed or fail in advance, but also help to reveal neural mechanisms or memory tasks. In this study, we investigated the possibility of decoding the performance of the memory task using intracranial EEG data. 2 epilepsy patients participated in this study, and 20 electrodes implanted in the right or left hippocampus for each patient respectively. The paradigm consists of encoding, distractor, and retrieval session. In the encoding session, 120 words were presented to the patient, and they were asked to memorize them as many as possible. In the distractor session, the patients were asked to solve a simple math task for at least 5 minutes. In the retrieval session, the patients were asked to retrieve the 120 words, and new 60 words were also presented along with the 120 words. And then patients were asked to press the 3 buttons depending on their memory, whether the words have been presented before, button 1, not presented before, button 2, or not sure, presented before, button 3. The intracranial EEG data were filtered with 2 kinds of filters, and then the filtered data were segmented into 2 periods, pre-task and task, based on onset time of presenting each word. We assigned the correctly remembered trials as correct, while forgotten and not sure trials were assigned as incorrect based on results of retrieval session. We extracted past features using continuous wavelet transforms, and the classification was performed using naive-based classifier based on 10 by 5-fold cross-validation. The figure shows the ERP maps of the 2 patients during the encoding session, which were obtained by averaging all channels and trials for correctly and incorrectly encoded words, respectively. The correct condition shows strong ERS around beta band for both patients. This result shows the decoding accuracy for each patient. The highest decoding accuracies of the pre-task and task were 75% and 79% when using delta power for both patients. The results demonstrated that the outcomes of the memory task can be successfully decoded before and during the encoding session using brain activity. We investigated the possibility of decoding the performance of the memory task using during and before encoding session data. We confound distinct brain activity patterns when successfully remembering and forgetting a specific item in the memory task. The delta power was a good feature to decode the performance of the memory task using before and during the encoding session. In our future studies, we plan to improve the decoding performance by introducing more advanced classification algorithms based on deep learning architectures. Thank you for listening, and if you have any questions, please leave a comment or email.